Over the last 3 entire years, TSMC spent a combined $101 billion building out their global manufacturing capabilities.
Yeah, and this year alone, in just 12 months, they are preparing to spend up to $56 billion.
Right. And that massive sudden spike in capital isn't just like a boring accounting detail.
No, not at all. That is the physical cost of artificial intelligence shifting from simply answering our questions to actively doing our jobs.
Welcome to the deep dive. If you are listening to this right now, you are probably trying to figure out exactly what is driving the global tech economy.
Right, and how these massive forces are going to impact the tools you use every single day.
Exactly. So today we are opening up a massive stack of sources. We have the official Q1 2026 earnings call transcript, financial press releases, some highly technical presentation decks, and fresh news analyses.
And all of this is focusing on TSMC, the Taiwan Semiconductor Manufacturing Company.
Our mission today is to decode these incredibly dense financial documents and, extract the true story behind the numbers.
Because we aren't just looking at spreadsheets here, we are looking at the physical limits of the AI boom.
Yeah, and what a multi-billion-dollar bet on the future of human computing actually looks like on the ground.
Right. TSMC just posted a record-breaking quarter, and the headlines are all pointing to AI as the engine.
But the most fascinating part of these documents isn't just how much money they made. It's why they are suddenly breaking their own decades-old ironclad rules for how they build their factories.
It's a huge pivot for them.
So let's jump right into the deep end. The headline numbers for Q1 2026 are honestly staggering. Revenue hit $35.9 billion US dollars.
Which is 1.134 trillion new Taiwan dollars.
Right, up 40.6% year over year. Profits jumped 58%. And their gross margin hit 66.2%, which beat their own guidance.
That margin is incredible.
Okay, let's unpack this. 66% gross margin in physical hardware manufacturing is wild. Are we just seeing the results of a monopoly jacking up prices because they are the only game in town?
I mean, they certainly have immense pricing power because they operate at the absolute pinnacle of their field. But the margins require a bit more nuance.
Okay, how so?
If you dig into the earnings call, that 66.2% gross margin and their 58.1% operating margin is driven by a few intersecting factors.
Like what?
Well, there are relentless cost improvements, a favorable foreign exchange rate, and incredibly high capacity utilization rates.
Meaning their factories are just running nonstop.
Exactly, running at maximum efficiency without idle downtime. But the foundation of all of this, the reason they can maintain those rates, is what they call their leading-edge process technologies.
The nanometers. We see this jargon everywhere now. 3 nanometer, 5 nanometer, 7 nanometer.
Yeah, the famous nanometer metric.
The earnings report says 3 nanometer accounted for 25% of their wafer revenue. 5 nanometer was 36%.
And if you combine that with the 13% from 7 nanometer, these advanced technologies make up 74% of their total revenue.
That's massive. So when they say 3 nanometer, is that just the overall physical size of the chip? Like they are just making the square of silicon smaller so it fits into thinner devices?
Not quite the whole chip, no. The nanometer measurement historically refers to the size of the individual transistors crammed inside that chip.
Okay, transistors.
Right. To visualize this, a single strand of human hair is roughly 80 to 100,000 nanometers wide. We are talking about engineering at the literal atomic scale.
Wow. So they are carving literal billions of microscopic switches onto a piece of silicon the size of a fingernail.
That is the reality of it. And the reason they want those transistors to be smaller, moving from 7 down to 5 down to 3 all, comes back to physics.
Less space to travel.
Exactly. When transistors are smaller, the distance an electrical signal has to travel is shorter. A shorter distance means the calculation happens faster.
Makes sense.
But more importantly, anytime electricity moves through a material, it encounters resistance, and resistance generates heat.
And heat is the ultimate enemy of electronics.
The absolute enemy. If you pack 50 billion transistors onto a chip, the thermal output is enormous.
So smaller is cooler.
Right. By shrinking the components to the 3 nanometer scale, you exponentially increase the processing power while significantly reducing the amount of energy wasted as heat per calculation.
Which is exactly what modern data centers require. It explains why these advanced hyper-efficient chips are making up nearly 3/4 of the money TSMC brings in.
The engineering is so difficult that clients are willing to pay a massive premium for those efficiency gains.
Absolutely. And before we get too deep into the billions of dollars moving around here, I want to smoothly drop this in. Just a quick reminder for you listening, all the information and analysis we are discussing here are purely to help you better understand the market and do not constitute investment advice.
Good to point out.
Yeah, investing involves risks, so please make sure to do your thorough homework before entering the market or consult a professional financial advisor.
Always a necessary reminder, particularly when we are looking at an industry that is shifting as rapidly as semiconductors.
So let's look at that shift. Let's talk about where these billions of microscopic switches are actually going.
It's changing fast.
For the longest time, smartphones were the undisputed king of the chip industry. Every fall, a new flagship phone required a new flagship chip.
Right.
But in this Q1 report, smartphone revenue actually dropped 11%. Instead, high-performance computing, or HPC, surged 20%.
Yeah. HPC now makes up a massive 61% of TSMC's total revenue. The speed of that transition is just remarkable.
So HPC is basically the AI stuff, right?
Exactly. It's the category that houses the artificial intelligence chips, the heavy-duty processors going into massive data centers to train and run AI models. It has completely dethroned the smartphone.
But I have to push back a little here. Looking at the broader tech landscape, haven't we kind of hit peak AI hype?
What do you mean?
Well, we all played with the text chatbots a few years ago. Everyone has generated a funny image by now. Why is the demand for these specific HPC chips still accelerating so aggressively right now?
It's a great question.
Like, what is driving this sudden second wave of demand?
The answer from TSMC's leadership reveals a fundamental shift in the actual architecture of how AI is being used across industries.
Okay.
During the earnings call, CEO C.C. Wei highlighted the transition from generative AI to agentic AI.
Generative to agentic. Okay, I'm assuming generative is the chatbot phase we just went through.
Yes, exactly. Generative AI is essentially query mode. You ask a chatbot to write a summary of a document, and it generates a single answer based on its training data.
Right, a one-to-one interaction.
You prompt it, it replies, and the task is done. Agentic AI is the command and action mode. You aren't just asking a question, you are giving an AI a broad goal.
Oh, interesting.
Yeah, the AI then acts as an autonomous agent. It breaks the goal down into multiple steps, interacts with different software tools, runs searches, evaluates its own progress, and course corrects along the way to achieve that final objective.
So instead of saying, write me a recipe for dinner, agentic AI is like, monitor my fridge inventory, cross-reference it with my dietary restrictions, order the missing groceries within a $50 budget, and schedule the delivery for when my calendar says I'll be home.
That captures the workflow perfectly.
That sounds intense.
It is. Now, why does this matter for a hardware manufacturer? Because agentic workflows require an exponential step up in what the industry calls token consumption.
Token consumption. Remind me what a token is.
A token is the fundamental unit of data and AI processes. Think of it like a piece of a word.
Okay, got it.
When an AI acts as an agent, it is constantly running continuous background tasks, verifying data, and having internal monologues before it ever presents a final result to you.
So it's thinking 100 times more than a simple chatbot before it takes action.
Exactly. And that thinking translates directly into millions of tokens being processed continuously. This requires an unbelievable amount of raw computing power.
I can imagine.
Data centers are currently struggling with the thermal output and the sheer power demands of this level of token consumption.
The infrastructure physically has to catch up to the ambition of the software, which completely recontextualizes TSMC's confidence.
Absolutely.
They stated they expect their full year 2026 revenue to grow by over 30% in US dollar terms.
Yeah, they're essentially saying the software developers are building sprawling digital cities that require an electrical grid that doesn't physically exist yet, and we're the only ones holding the blueprints for that grid.
It leads directly into the physical reality of navigating this AI megatrend. If demand is skyrocketing to support agentic token consumption, how does a physical manufacturing company actually keep up?
Right, especially one constrained by concrete, steel, extreme clean rooms, and highly specialized lithography machinery.
It has to keep up with software that can scale infinitely. And this brings us to the part of the sources that really caught my eye. Because to keep up, TSMC is actually breaking its own golden rule.
This was a big surprise.
Historically, TSMC has operated on a very strict practice. They do not add additional capacity to a specific node, like 3 nanometer, once it reaches its initial targeted capacity.
Right. The traditional playbook was to build the factory for the node, fill it up with orders, and then focus all future capital on developing the next smaller node.
But right now, they are abandoning that rule completely.
The demand for 3 nanometer technology is just so robust. And it's driven not just by agentic AI data centers, but also the remaining smartphone market and increasingly complex automotive computing needs.
So their traditional model simply broke under the pressure.
Basically, yeah. So they are executing a massive global capacity expansion plan specifically dedicated to the 3 nanometer node.
And the geographic footprint of this expansion is huge. The documents outline a new 3 nanometer fab being added in Tainan, Taiwan, with volume production scheduled for the first half of 2027.
That's moving fast.
Then, a second fab in Arizona will utilize 3 nanometer tech, hitting volume production in the second half of 2027. On top of that, a second fab in Japan is slated for volume production in 2028.
Building these facilities, particularly for extreme ultraviolet lithography required at the 3 nanometer scale, demands staggering amounts of capital.
Which explains the price tag we mentioned at the start, the capital expenditures, or CapEx. TSMC expects to spend between $52 billion and $56 billion for 2026 alone.
And management noted they fully expect to hit the high end of that range.
$56 billion in 1 year. Is this level of spending reckless? I mean, they are breaking their own rules to build factories for a technology trend that is moving at warp speed. What happens if the AI demand suddenly plateaus?
It is a logical concern, but we have to look at the historical corporate culture of TSMC. Their management team is notoriously conservative with capital.
They aren't risk takers.
No, they do not build Field of Dreams factories. They don't build a $50 billion facility hoping the customers will eventually show up.
So they already have the buyers lined up.
They are committing this capital because they have incredibly strong, multi-year, locked-in signals from their customers, specifically the major cloud service providers. They are fully sold out.
Wow.
Right now, the AI revolution isn't constrained by a lack of ideas. It is heavily resource constrained by TSMC's physical ability to print the chips.
They literally cannot cure the silicon fast enough to meet the orders already on the books.
And they are fully aware that simply printing more 3 nanometer chips won't solve the long-term physics problems. During the call, management briefly introduced CoPo.
CoPoS, what's that?
It's a next-generation advanced packaging technology currently in pilot run.
Advanced packaging. What does that actually mean? Are they just putting the chips in better boxes?
Not quite. It goes back to the physical limits of Moore's law. As it gets physically harder and astronomically more expensive to shrink transistors past 3 nanometers, you start running into quantum tunneling issues.
Quantum tunneling?
Yeah, where electrons literally jump the microscopic barriers. So the next frontier in performance is how you package different components together.
Okay, I follow.
Instead of trying to build one massive, incredibly complex chip, advanced packaging takes smaller, highly specialized chiplets.
Yeah.
Maybe one for memory, one for processing, one for graphics.
And it packages them together.
Exactly, so closely and efficiently that they communicate as a single unified brain. The fact that CoPoS is already in pilot runs shows TSMC is engineering workarounds for the physical bottlenecks we will hit 3 or 4 years from now.
Okay, let's take a step back and look at the whole picture here. We have record revenues, record 66% margins, a virtual monopoly on the world's most advanced computing hardware, a technology roadmap that stretches years into the future, and $56 billion being poured into global expansion to meet insatiable, locked-in demand.
It paints a very rosy picture.
Right. So why did the stock drop 3% immediately after this earnings report went public? What is Wall Street seeing that we aren't?
Well, that disconnect highlights the tension between Wall Street's expectations for absolute perfection and the grounded reality of industrial manufacturing.
Expectations were just too high.
Exactly. When a company's valuation assumes flawless execution indefinitely, even slightly conservative commentary about the future can spook fast money investors. And TSMC's management, to their credit, did not use the earnings call as just a victory lap. They were very transparent about the real physical headwinds they're facing.
Yeah, reading through the transcript, there are definitely some storm clouds on the horizon. Management specifically brought up margin dilution.
This is a big one.
Now, hold on. We just established that their smallest, most advanced chips are their biggest cash cows. So why did they warn that rolling out their upcoming 2 nanometer technology, known as N2, is going to hurt their profit margins?
Because pioneering the next frontier of physics is brutally expensive.
How so?
Developing the 2-nanometer node requires entirely new, cutting-edge manufacturing equipment, massive research and development expenditures, and a crucial metric called yield.
Yield, meaning how many actually work.
Exactly. When you first start printing silicon wafers at a new, impossibly small scale, the percentage of chips on that wafer that actually work perfectly is naturally lower.
So they are essentially throwing away a lot of defective, highly expensive silicon until they perfect the process.
That's exactly it. They have to run the factories, consume the materials, and pay the engineers, but they get fewer sellable chips out the door initially.
Ouch.
Yeah, management explicitly warned that this initial ramp-up of N2 will dilute or reduce their overall gross margins by 2 to 3% in the second half of 2026.
So it's the steep toll of staying at the absolute cutting edge. You have to take a financial hit to build the bridge to the next decade of dominance.
Precisely. And that wasn't the only headwind.
Right. They also pointed out persistent consumer weakness. AI data centers are buying everything in sight, but the everyday consumer is feeling the pinch.
The enterprise side is booming, but traditional consumer markets, your standard mid-tier smartphones and personal computers, remain sluggish.
What's driving that?
A significant factor here is the rising cost of memory components. As memory prices hike up, it squeezes the profit margins of PC and phone manufacturers.
So they have to raise prices.
Right. They either absorb the cost or pass it to the consumer, which suppresses overall demand in those highly price-sensitive markets.
It's a domino effect. And then there is the massive, unavoidable risk that every global manufacturer has to navigate: geopolitics and macroeconomic stability.
You simply can't ignore the map when you run a global supply chain. TSMC acknowledged that the ongoing situation in the Middle East is causing macroeconomic uncertainty. When you run manufacturing facilities that require absolute microscopic precision and uninterrupted supply lines, regional conflict anywhere in the world is a major risk factor.
I noticed in the supply chain reports they specifically mentioned securing specialty chemicals and gases, specifically calling out helium and hydrogen. Why are those so critical to making a computer chip?
Making a leading-edge semiconductor is arguably the most complex manufacturing process humanity has ever devised.
Really?
Oh yeah. It requires extreme vacuums, ultra-pure clean room environments, and precise temperature controls at the atomic level. Helium is absolutely crucial for cooling the silicon wafers during the intense heat of the manufacturing process.
And the hydrogen?
Highly purified hydrogen is used to clean the wafers, ensuring there are zero microscopic defects before the circuits are printed.
So if a conflict disrupts the shipping routes for specialized hydrogen, the entire 3-nanometer production line could theoretically halt.
Which is why TSMC is proactively developing robust, multi-source global supply chains for these critical materials. They are spending millions just to ensure they aren't caught off guard by regional disruptions that are completely out of their control.
It really highlights how physically fragile the foundation of the digital world is. Speaking of competition and interconnectedness, there was a narrative floating around in the financial press prior to this call.
The rumors about losing customers.
Yeah. The theory was that because TSMC is so entirely consumed with meeting this massive AI demand, competitors like Intel or Samsung might swoop in and try to steal TSMC's traditional customers who feel ignored. Did management address this dynamic?
They did. An analyst directly asked if TSMC would prioritize certain highly profitable AI clients over their legacy customers.
What did they say?
CEO C.C. Wei's response was very firm, and it's important we impartially report his stance here. He stated unequivocally that TSMC will not purposefully select or favor any single customer.
So everyone gets fair treatment.
That's their official strategy. They're working to increase supply fairly across the board to support all their clients, regardless of whether they are building AI supercomputers or standard automotive sensors.
Whether that strict neutrality holds off the competition in the long run remains to be seen, but their stated commitment is loyalty to their entire customer base.
Exactly.
Okay, we have covered an immense amount of ground today. Let's bring it all together for everyone listening. TSMC just delivered a blowout first quarter for 2026.
Driven by those advanced chips.
Right. The engine of this massive growth is their advanced chips, the 7, 5, and 3-nanometer technologies, which now make up 74% of their total wafer revenue.
We are witnessing a historic changing of the guard in technology. High-performance computing, driven by the explosive compute needs of artificial intelligence, has officially dethroned the smartphone as the primary driver of TSMC's business.
And it is all being accelerated by the shift from generative AI to agentic AI. The software is becoming autonomous, it's devouring tokens and complex background loops, and it requires so much raw computing power that TSMC is breaking its own historical rules about capacity expansion.
They're preparing to spend up to $56 billion this year alone to build new 3-nanometer fabrication plants in Taiwan, the U.S., and Japan.
Yeah.
Yet they are executing this unprecedented expansion while navigating a sluggish everyday consumer market, global geopolitical instability, and the physical reality that pioneering the next generation of 2-nanometer chips will temporarily squeeze their profit margins.
It is a delicate, incredibly high-stakes balancing act, a $56 billion balancing
Well,
act.
it really is.
It is endlessly fascinating when you peek behind the curtain of the devices we take for granted. Before we wrap up, what is the one big takeaway, the thought you want to leave our listener with today?
Well, think about this. If agentic AI truly represents a near future, where computers don't just answer our prompts, but autonomously execute complex labor, and TSMC is currently the sole entity holding the physical keys to print the computing power required for that leap, are we just analyzing a traditional hardware manufacturer, or are we looking at the invisible architect of the next global workforce?
The invisible architect. We started this deep dive looking for the financial health of a single company, but what we found is the incredibly complex, breathtaking blueprint of the future being built in real time. Thank you for joining us on this deep dive. Keep questioning the technology you use every single day, because the story of how it physically gets to your hands is changing faster than ever. See you next time.